Good day, ladies and gentlemen. Today we are going to solve Leetcode's new problem, Unique Part 2 with dynamic programming bottom-up approach. Yesterday we solved Unique Path 1, which was 60-second problem, and I will link that problem into solution into description somewhere, or you can find that into cards. So what we are doing in this problem, we are actually following exactly same pattern, but we are just going to add couple of more conditions based on the complexity of this problem. Let's start with the question first. What's happening in the question? Okay, again we have source and destination. We have to find number of unique paths that could lead to the destination from the source. But there are two constraints here. One constraint is that in this question we also have some obstacles, so you cannot pass the obstacles. If there is obstacles, then that cell is dead. Okay, then second constraint is that you can only traverse to the bottom and the right hand side. So those are the only two constraints. Given that, let's understand the question first and then we'll dig down into the algorithm. Okay, the first question, you will see the source is that Android thing. Follow my cursor on the screen. Source is that Android thing, the destination is the star, and this red rock is the obstacle. So they are representing the obstacle with 1, as you can see here, and rest everything is represented with the 0. So 0 means space, 1 means obstacle. So how many unique path are there, given that there is an obstacle in the center? So there is this 1 from the top, there is this 1 from the bottom. Those are the only two paths, unique path are there. Okay, example 2. If obstacle there in the 2D grid, in the grid with 4 cells, then there is only one path, right? Okay, fairly straightforward question. Let's see how to do that. Okay, let me pull out my notes here. Okay, on the screen what you can see on the left hand side is called obstacle grid. It's an input grid. On the right hand side we have DP grid. That is the grid that we are going to design to solve this question. The first constraint, the obstacle is represented by 1 and the space is represented by 0. Okay, the first condition, it's a edge condition actually. If you have obstacle in the first cell to the start cell, then you cannot form any path because there is no starting point. Same way, if you have obstacle in the end cell at the destination, then you cannot form the path because there is nowhere you can go, right? So the first condition would be there has to be a space or 0 in the first cell or in the last cell. So let's first write down that condition. Here what I'm going to do is I'm going to store the length of the row and the column in variables. So we are going to use those variables quite often, so it's good practice to store them somewhere. So row length is equal to this obstacle. What I'm going to do, I'm going to pull this down. Okay, so row length is going to be length of the grid, and integer let's call column length would be length of the first row. Okay, now that we have our first best condition, if the obstacle grids first cell, right, so that 0th and 0th cell has 1, that means 1 means obstacle, or obstacle's last cell, that means row length minus 1 and column length minus 1, has 1 in it, means obstacle, then simply return 0. That's your best condition. All right. Once we are done with that, if there is no 1, that means there is 0. If there is 0, let's divide this problem into sub problem. Let's say there is only one cell which is representing source and path both, source and destination both. If the source and destination is same, that means you only took one. There is only one unique path to reach from source to destination. So if the first cell has a 0, then simply return 1. Okay, you will also realize that all of the cell values here are 0 because a DP array is integer type and default value of integer is 0. Okay, so that's why those are zeros. But yeah, come back to the first cell. If the first cell has a 0, then simply allocate the 1, but because there's only one path you can take into DP array. So let's do that. For that we need to iterate through both of the arrays, right? So let's do that. Integer row is equal to 0, then obstacle, my bad, row is less than row length and row plus plus. So we are iterating through rows here, and now let's iterate through each column of each row. So 0 column is less than, what is that, col length and column plus plus. Okay, straightforward. Okay, one thing I also need to do, we have to initialize dp array, right? So our dp array is nothing but integer jagged array. So let's call that here. Let's initialize the jagged array. When you initialize the jagged array, you have to give how much of a space you want it. So we are going to keep the same as our obstacle grid's length. Then we have to initialize each row of that jagged array. So each row would be new integer array with the same column length. Okay, now back to our algorithm. What do we need? If our first cell, that means a row, is double equal to 0, or our column is double equal to 0, then what we are saying is, then our dp of row and column, that means our first row and first cell, will have 1, and we continue. Okay, so that is this condition. Now let's say you have only first row, or let's create the algorithm just for the first row. Okay, if the value is 0, then we are going to assign it 1, we just saw. If obstacle grid has 1, that means it's a block. There is an obstacle in the cell, simply ignore that cell, do nothing. Why? That's what we are going to find out here. In the next cell, when the cell value is 0, then check what was the cell value in previous cell. That means you are checking if previous cell value was an obstacle or was a space. If it is an obstacle, then keep the same obstacle, right? What I'm trying to say here, let me insert a table here. Okay, let's say you have path from going from here, but then you found an obstacle. If you found an obstacle anywhere in the row or column, that means all the other cell which are after that are not going to form a unique path, because those are blocked by this cell, right? So same way, in order to achieve this, what we are doing is, if we have the 0, that means space, then we are checking if the previous cell was blocked or not. In this case, when we form the dp array, we are ignoring all the obstacle paths, so it will keep the default value of 0, which is an integer type. And then in the next cell, when the 0 comes along, we are checking if previous cell value was blocked. Yes, it was blocked. That's why we are going to keep the same block here forward. How do we code that? All right, if the row is the first row and our obstacle grid first row, that means 0, and for all the columns is 0, let me pull this little bit up. Okay, we are going to update the dp of first row and column would be dp of previous cell value, assign the whatever previous cell was holding. So we're gonna say dp of same row but previous cell, so column -1. See, and then continue. Now same logic for columns. Let's say there is only one column, or what happens for the first column. If it is 0, then we are going to assign 1. If it's an obstacle, we are going to ignore. If it is obstacle, we are going to ignore. If it is a space, then we are going to check if previous cell was obstacle or not. Yes, previous cell was obstacle, so we are going to copy the value from previous cell and assign it to here. Now let's say our input was only this much, then how many paths are you forming? 0 paths. That's why you're storing the 0 automatically in the last cell. Same goes here. All right, let's follow this code for column as well. If column was 0 and obstacle of row but 0th column, is double equal to 0, then what we are doing is we are upgrading a DP grade with different rows but the same column to be DP of previous row value minus 1 and the same column, and then continue. All right, now that was for row, so this is first row, row, this is your first column. Okay, then one more thing we did, what we did is we are ignoring all the cells with the obstacle. So let's do that as well here in the top. Let's do that at the beginning so we don't have to go through each if cases. If you know your obstacle grid, right, your obstacle grid of row and column, if that is a blocker 1, then simply say continue because we are going to ignore. Okay, now to the very last test case. Let's say we have grid like this. Okay, so what we are going to do, first cell, if the value is space, that means assign 1. You can form the path, yes, you can form path here, yes. Now at this cell you're coming the path, at this cell the unique path is coming from 2 different places, so we are going to summarize the value of those 2 unique paths. So 1 plus 1 2, because till this cell there is a 1 unique path, till this cell there is 1 unique path. That means in order to reach this cell there are 2 different unique paths. So we are going to code that out. Oops, what did I do? So we are going to say DP of row and column would be DP of row minus 1 and the same column plus DP of row but previous column minus 1. Right, now let's run this drill and see if that works with both of the example. Okay, so this is what your first example looks like. Okay, let's see what's going to happen in DP array. First, if the value is 0, we're assigning the cell value to be 1. Okay, are you able to form the path? Yes, you are. Are you able to form the path? Yes, you are. Are you able to form path here? Yes, you are. Here, yes, you are. Since the values are zeros, that means we're able to form the path. Okay, now so what's exactly happening here? Let me show you here. So if the value is 0, we are just copying the value from the previous cell, right? So in this example, what we did here, when the value was 0, we are just copied the value of previous cell, which was 1. Again, value was 0 here, we copied the value from previous cell, which was 1. So that's why this 1s and 1s are coming. Now here the value is 1. That means we are not able to, so we are going to ignore the value. What we did in algorithm, we simply continued, we ignored that value. So we are going to keep that as it is. We are going to ignore that it is. Now here, when it comes to this cell when there are 2 different paths to choose from, what we are doing, we are actually summarizing the values of both the cells. So what we are going to do in here, oops, we are going to summarize 0 plus 1, which will lead us to 1. Same way here, we are going to summarize 1 plus 0, which is 1. Again, at the last, we are going to summarize 1 plus 1, 2. And if you can see, the 2 is the output for this particular example. Same way for example 2, we have a grid which looks like this. Let's form the grid. We are going, first cell would be 1. Next is the obstacle, so we're going to leave it alone. Then again the value is 0, so we're going to copy the value from the previous cell, which is 1. So right here. And then now we have 2 cells to choose from, so we are going to choose 1 here. So in the end, there is only 1 path you can form, which was the answer here. Alright, so algorithm seems to be working, and we are storing the value in the last cell. So let's go and do that. We're going to return DP of row len, right, minus 1 and call len minus 1, and that should do it. Let's run this. Okay, test cases have been passed. Let's see, drum roll please. Wrong answer, we messed up somewhere. Let's see what's happening. So 29th test case where we have 1 1 1 2 1 3. Okay, let's see what's happening here. So 0 0 1 1 0 0. So technically 0 should be the output. why we are returning 1 here? That's wrong. Oh, here for the my bad, we are doing, or this should be and, right? Because first cell should be row and column, both should be and. My bad. Let's submit this and see what happens. Now I'm not gonna play drum rolls. It did not execute. Oh, it executed. Okay, drum roll is executed. So 75 milliseconds, 82.15, whatever those numbers are. But let's understand time and space complexity here. Time is very straightforward. Two for loops has been used. We are calculating the operation. We are running the operations for each cell, and each cells are represented by each cells of the grid. So that means we have time complexity of big of m into n. M represent your rows, n represent your column. Okay, space we did create our dp grids to store all the values of cells. So again, m into n. Okay, let me explain that with an example. So for example, here we had what, m is 3, n is 3, so 3 into 3, 9. So we created the dp cell of 9 cells, sorry, dp array of 9 cells. That's why that space complexity, and we run the drill for each of the cells. That's why this time complexity. So that's how we are coming to this space and time complexity. And thank you so much for this one. Next time we are trying to solve some other problem. But yeah, thank you so much for joining. I'll see you next one. Ciao.